Okay, leveling up, slope-intercept form. Here we go, concept A. Example 1, find intercepts from a graph. Find the x and y intercepts of the following line. Okay, so I'm going to remember that the x-intercept is where the graph or the line hits the x-axis. So I'm going to go along this x-axis and look for the point where the given line hits it, intersects it. That is at 4, 4 on the x-coordinate, 0 on the y-coordinate. So our x-intercept is at 4, 0. And then I'm going to look, and I'm going to use blue. I'm going to look for the y-intercept. The y-intercept is traveling along the y-axis. And wherever the given graph hits the y-axis, and that is this point right here. So the coordinates of that are 0 because it didn't move left or right, and 1, 2, 3. Up 3. Okay, so what? To find the x-intercept of this line, we need to find the point where the line crosses the x-axis. We found that. And what are the coordinates of the x-intercept of the line in the graph? The x-intercept was at 4, 0. Okay, and to find the y, we do the same. We follow it along the y-axis, and this is changing based on the one that was in the original. But we found that it was at 0, 3. Alright, and there is how you find your x and y intercepts. Okay, second example, find the slope from a graph. Find the slope of the following line by identifying the rise and run between the two given points, A, -1, 4, and B, 2, -1. Okay, well they made our job. They have done half the work because they've already identified the points for us. So now, since it's on a graph, it's just a counting game. So if I remember back, slope is the rise and the run. It's that ratio between the rise and the run. And slope is typically, traditionally, represented by m. So I'm going to write it over here. M equals, well, how far up did I go? So 1, 2, 3, 4, 5, 6. And I didn't go up, so the direction of it tells us whether it's positive or negative. So since we went down, it's -6 over our run, which will be 1, 2, 3. Okay, so -6 divided by 3, that can reduce down to -2. Alright, to find the rise, calculate the difference between the y-coordinates of the 2 points. To get from point A to point B, you must go down 6 units, so the rise is -6. Because we had to go down. It had that direction quality. Okay, to find the run, calculate the difference between the x-coordinates, because that's our horizontal distance. To get from point A to point B, we must go right 3 units. So the run is +3. Right, so then we already simplified this. What is the slope of the line? Slope is -2. There we go. Alright, let's move on to concept B, writing our equations in slope-intercept form. Alright, consider the following graph of a line. What is the slope-intercept form of this equation? For this line. What is the equation for this line? Alright, we're going to choose 2 points that on this line. They could be anything, and the simplest points to locate are the ones that intersect at whole integer numbers, because those are the easiest ones to put coordinates to. So I'm going to look, this one doesn't enter at 0, 0, there's not an intersection. Oh, yes there is. Okay, it's not at 0, 0, but it is at 0, 2. So that is a good one. But I guess they're asking us, I should read this question. Okay, which answer choice gives the coordinates of 2 points that are on the line in the graph? Okay, so let's check this. -3 and 2.5. So if I go back 3, am I up 2.5? Yes. And 5, 1. So if I go over 5 and up 1, am I on the graph, on the line? Yes. So that one is giving us the coordinates that are on the graph. On the line. Okay. Although it's close, this one doesn't actually lie on the line. Well, it looked like it, so I apologize. So we'll try again. Well, we know 5, 1 does. So let's check the other option that has 5, 1. So -5, 3. So if we go back 5 and up 3, yes, that looks like it hits the intersection. Well, it looks like it hits the line. So let's try that one. Yes. Okay, these ones were easy to identify. And the reason why the 2.5 one didn't work, that's a great learning opportunity to look back over this, is because I looked at this and I said, okay, -3 up 2.5. And I looked at this point right here and I said, yeah, that looks about at the value 2.5 on this line. And with coordinates, we have to be exact. And so the reason why whole number integers right here are easy to identify the points at those is because they intersect beautifully at the where the little grids meet in the corner. So there's no approximating in this. Okay, find the slope of the line using the slope formula and substitute the coordinates 5, 1 for x1, y1 and -5, 3 for x2, y2. Okay, I'm going to challenge this and ask the question, well, what if I just went through this and I didn't substitute? What if I substituted the other way? What if I made 5, 1 x2, y2? Would it matter? And what if I made -5, 3 x1, y1. And because I have this, I'm going to work it out both ways because I really like to see it visually. I'm a very visual person. So I'm going to graph these points, 5, 1, 5, 1, and negative 5, 3. Okay, so these are the 2 points. And they want to know how steep is this line, or what's the rate of change that line is going through between these 2 points. So I'm going to do this graphically so that when we do the algebra we can make sure that it is correct. So if I ended here, let's just count this. Okay, here we go. This is my x2, y2, x1, y1. So in order to get to my last point, I've got to go down 1, 2. So that is my rise. It's negative 2 because we went down. And the run would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 2/10, which reduces down to negative 1/5. Okay, so now let's do the algebra and see if we work it out correctly. So the slope is y2 minus y2 minus y1. First, that's finding our vertical distance. That's what we did first. We found our vertical distance. So now we're going to find our vertical distance algebraically. So 1 minus 3 divided by our horizontal distance, which is 5 minus negative 5. Okay, here we go. 1 minus 3 reduces or simplifies down to negative 2. And 5 minus negative 5, that double negative is our plus. So 5 plus 5 is 10. Negative 2/10. Our slope is negative 1/5. Just like we said. Okay, so I'm going to see if they want it in reduced form since we did reduce it. If not, we'll type it back in. Yep. Alright, so it doesn't matter if you switch around both labels to the coordinates. If you're going to change them, you have to change both the x value and the y value. So if I had made 5, 1 and I just changed this 5 to x2 and left this 1 as y1, it would be incorrect. You have to change both labels for both coordinates. But the order doesn't matter as long as you label both coordinates with the same sub-label, x2, y2, x1, y1. Okay, so substitute m equals negative 1/5, x equals 5, and y equals 1 into the slope-intercept form for the equation of the line y equals mx plus b. To get that 1 equals, because 1 is where the y is, and that is what they told us the value of y was. Negative 1/5 is where the m is, and so they replaced that right here, and then they replaced x with 5, and now we have to solve for b, which is our y-intercept. So we have 1 equals, now this is multiplication between m and x, so negative 1/5 times 5 is negative 1 plus b. Alright, to solve for b, we have to isolate b. So I'm looking at this -1. The inverse operation would be to add 1. I want to make it 0 on this side. So this is -1 plus 1 is 0 plus b equals, there's our equal sign, 1 plus 1 is 2. So this is going to be, let's simplify let's reduce this. 0 plus b, that's b. So our b value is 2. Okay, now that we've solved for both the slope and the y-intercept, all we have to do is to substitute these values into the equation for the slope-intercept form. So helpful tip, memorize y equals mx plus b. Memorize that. That is slope-intercept form. And so, when you're given an m, you can replace it -1/5 x plus, and they give you the y-intercept. Alright, y-intercept is a coordinate, so this really should be 0, 2, and you'll probably see that later on. The y-intercept value of the y value of your y-intercept coordinate is 2. So that is where you replace your b with. You don't have a y value or an x value that is arbitrary. Okay. We could have done that. There's a different one. And that's from 2 points. Okay, so now, for those of you who are algebraic, you may want to add that into your notes right here. And just write it down. This is for slope-intercept form from 2 points. And then you could have done it that way. Alright, concept C, writing equations for situations. Write an equation to model a situation. As the clock strikes noon, Stana passes mile marker 31 on the loop 505 freeway and sets her cruise control to 75 miles per hour. Write the equation in slope-intercept form for a linear function whose output represents what mile marker Stana is at. Okay, so I'm going to draw a graph really fast to visualize what they mean by the output. Output represents what mile marker Stana is at. So your output is represented by the y-axis. So this is mile marker, and I'm going to just use mm to represent mile marker. So our y-axis is going to be mile marker, and our cruise control was 75 miles an hour. Okay, so identify the constant rate of change in the problem. What is our slope? Well, a really big key word is per for a rate. You're going miles per hour. That's the rate you're going each hour. So on this, 75 miles per hour. That is our slope. We are changing 75 miles in 1 hour. Okay, identify the initial value. Okay, there are 2 initial values in this problem, the initial time noon and the initial mile marker 31. Since our function is supposed to output the mile marker Santa is at, which initial value should you use for your equation? Okay, well, they laid it out for you. The output is the mile marker. Okay, and we even labeled it right here. And I used mm for mile marker. That's the y-axis for our graph. So that is our output. That is 31. That is our initial value, our y-intercept. Okay, determine what x and y represent. Well, we already know what y represents. It represents our mile markers. The output of your linear function is the mile marker Santa is at, so the variable y has units of miles. Considering that the constant rate of change, or our slope, 75 miles per hour, has units of miles per hour, or miles divided by hour, what should the input variable x represent? It should be our hours, the number of hours past noon, because that is when she started to take time, notice of time. Okay, so now write the equation in slope-intercept form. So again, memorize it. Y equals mx plus b. Okay, so far we have determined that our slope is 75 miles per hour. So I'm going to rewrite this. Y equals, our m was 75. So wherever m was, I'm writing 75. I did not have a value for x, so that is going to stay as x plus, did I have a value for b? Yes, 31. So I'm going to replace b with 31. And then I'm looking for this equation. Alright, y equals 75x. Well, here's my y equals, but that starts with 31x, so nope. And the reason why I'm ignoring this one is because it starts off with x equals and x equals. So my two options left are these two. So this one has the correct slope, 75x plus 31. There we go. And that's how you replace information. So keywords are per, so anything like feet per second, that is a change. That's a rate of change. So that would be indicative of a slope. Any kind, you get paid $8 per hour. That is a slope. That's a rate of pay, a rate of change. You are paid $8 per hour. So that's a really big keyword, is per, for an indicator of slope. And there's your examples.